Yeah, so this lab is called as Explore LangChain. So here you can find this install.md, which basically helps you to guides you to install the requirement. So already we have virtual environment, right? So outside the folder, so you will be having a new requirement.txt, right? See, already in our last session, we have already installed OpenAI and Anthropic and Python.env. So these are just like a placeholder. But these are the main new libraries which we'll be installing in this particular session, which will be helping us to integrate LangChain with our models. So you can see we have installed LangChain, LangChain Core, which is basically the core integrations. We'll be having core integrations in this. LangChain OpenAI to integrate OpenAI based things, Anthropic and Google GenAI. So we have to install these libraries. So how to install this libraries? Already we have an install.md, but however, I'll just guide through this. So you can open your terminal. You can be in this out in this particular lab itself, but you can just open the terminal. Okay. So once you open the terminal, like you can just drag here like this, or you can just go to terminal and just click on new terminal. You'll be able to see. So see that your virtual environment is activated. By any chance, if your virtual environment is not activated, use this command source venv bin activate to activate your virtual environment if you're in Linux, or you can just use this command to activate in Windows. Then you can just go inside the lab which we are working on. Okay, that is the lab to explore LangChain, and then here you can actually do pip install requirement.txt. Okay, you can just install the requirements. Already in my system, it's already installed, but however, you can install this. So once you have installed it, actually, guys, earlier I talked about the .env file, if you remember, right? So what you can do is you can actually put your .env file outside the folder, outside this lab folder here, like inside the main folder actually. So such that this env file can be used in all the labs. So in future you'll be having a lot of labs in this folder, right? So you will be basically seeing a lot of labs. So I would recommend you to, put this env file outside the main folder such that every lab folder can use it. Okay, instead of creating a separate env file in every folder. Okay. So once the setup is done, you'll be able to see two files here. One is explore LangChain and second one is a customer service agent.py. Two files. So let's start with understanding explore LangChain.py. So you can just open this. So let me go through the code here and explain you what is happening here. Okay. So first, so I will talk about this concept of prompt template soon, guys. Our upcoming sessions, we are having a dedicated session for talking about prompt template. But for now, understand this and understand that here we are using something called as prompt template from LangChain core.prompts to design and to write the prompt. Okay. But why we need a prompt template, we'll talk about that later eventually. So yes, but here we are importing something called as PromptTemplate class, which is basically helpful for us to write the prompt in a structured way. Next, here, if you carefully observe, this is the main important thing you have to understand. Here from LangChain chat models, okay, basically these are part of chat models, right? We are saying init chat model. What do I mean by init chat model? So it is like, I told you, right? LangChain is something which will be helping us to, unify all the LLM calls instead of calling separately, having separate functions, having separate output. We have only one function right now that is called as init chat model. And if you use this, you can integrate any model, whatever you want, in a just with small change. For example, now I'm initializing the chat model, right? So I'll show you how can you integrate any model you want. How can you just plug and play whatever model you want with just a simple change. Okay. So I'll show you that. And also then we are having something like, the .env. We are just loading the .env for the environment. Now you're initializing the LLM. So how are you initializing the LLM? You're saying LLM is equal to initialize chat model. And here, first you have to provide which model you want to use. Okay, so I want to use the Claude for Claude Sonnet for. Okay, so I just mentioned the ID of the model. That's it. So because we are already loading the environment file, automatically it will read the API key from the environment file. And here we can provide them, we have to provide the model provider. That's it. So you can see how easy it is to do that. Now, for example, I want to use Gemini. So you can just provide that, okay, the model provider is Google GenAI. Okay, it's called as Google GenAI. And which model you want to use. For example, I want to use Gemini 3.3 Pro preview, or for example, if I want to use Gemini 2.5 Flash. So like that, you can just mention. You can see how easy, right? Everything is same. The remaining code is exactly same. Even the content, output, everything is same. Just the provider changes. That is the main advantage of LangChain. For example, I want to try OpenAI. So I'll just try OpenAI and I'll just give some OpenAI model here. That's it. Okay. So like this, with just a small change, I can integrate whatever models I want to. Okay. And the same way, I can also integrate the open source models. Right now, we have not yet discussed about the open source, right? We are only focusing on closed source. But in future, once we discussed about Olama and the open source models, which is upcoming, I'll also show you how can you use the same LangChain. Everything is same. Just you change the LLM provider to Olama and just put whatever model you have. That's it. With a small changes. That's it. Okay. So we'll talk about that as well. So that is how you're initializing the LLM. Same way you're initializing the prompt as well. Okay, you're just saying prompt is equal to prompt template. Okay, which we already got it from the template from this one. From template, you're saying prompt template dot from template, and you're just writing a simple prompt. So here, this is a simple example of a customer service agent, guys. Okay, where what we are trying to do is imagine you're having a AI as a customer service agent who understands the user queries, who understand your users, users intent and answers the users, okay, on behalf of you. So you can see what you're saying here. You're just saying you're a customer service agent. Take this customer complaint. You're giving the complaint here issue. So this is like a placeholder, guys. Okay. So we'll talk about this. This is the most common thing we always use in prompt templates. So this is like in future you can say that like a dynamic variable. Okay. So take this customer complaint, analyze the sentiment. So we are doing these are the things which we are doing in this prompt. Okay. We are analyzing the sentiment, categorize the issue, which issue this belongs to, suggest a solution, and write a professional response. Also, check our knowledge base to escalate if needed. So, however, right now we are not giving the knowledge base, but in future, yes, we'll be working on this use case. Eventually, we'll be making it more real time soon. But yeah, we just started right now. So even though we don't have a knowledge base for now, we're just saying this. But yes, eventually we will, provide a knowledge base as well. And then we are just giving the issue here. Okay. So this is a placeholder, guys. So this is where the prompt template will come into the picture where, you can just give this as a placeholder. And when you are invoking this, LLM, you can provide this dynamic variable. Okay. This is like a placeholder. And also, if you know in Python, we are having formatting, right? In formatting, also we use this kind of thing, correct? So then we create this prompt. Now here comes the main part, that is the LCEL part, that is LangChain Expression Language. I told you, right? You can connect things using pipe symbol, and you can see here you are creating a chain. That is what I was talking about, LangChain. And here what I'm doing is whatever prompt I wrote, I'm feeding to the LLM. So you are just connecting the prompt with LLM using this pipe operator, pipeline operator. Basically, it's a pipe operator. You can see, right, how simple is you can feed. Now, it might look simple and you might think, okay, why do we need this? But eventually, when you do complex systems, this is, you'll understand the idea of why we need this pipeline. Okay. So, but yeah, you can see simple, you're just giving this prompt to the LLM. That's it. Simple as that, right? Prompt, you'll feed it to the LLM. So this is a chain. Okay, you're creating a chain. That is the reason it is called as LangChain. Okay, and it's a very simple chain with where you're just giving a simple prompt, whatever you're having to the LLM. Okay, and you're just doing invoking. So you're invoking this chain. So for invoking this chain, you should just call chain dot invoke. Now, while invoking, you have to dynamically pass the issue because here we are taking the issue, right? Here we are taking the issue as a placeholder, right? So we are dynamically passing the issue, something like this. You are assuming like a customer, and you can see customer says, I am having a trouble with my account. Okay. So that is the idea, and you are getting the response. Now, as you know, already we have seen the response will have a lot of things along with your actual content, like the token usage and everything. But if you want to actually see the actual content, it is responsive content. And the advantage of this LangChain is if you properly observe, in the closed source models, whatever we are seeing, the actual response was in different locations. For example, in OpenAI, if you see, the response was somewhere here, choices of zero, dot message, or dot content. Whereas in Gemini, it was in just result dot text. Whereas in Claude, it was again different, right? But in LangChain, it is always response dot content. no change. Whatever model you use OpenAI model, you use Anthropic model, you use any model provider you use, the content is even if you use any other open source model also, the response will be always in content. So you can see that is the reason why I say plug and play. So everything is same, just to change the model, the entire code is same. That is the advantage of this one. Okay. So now let's run this first. So let's run this and see how this output looks. So basically the idea is we will the LLM will understand the sentiment of that particular issue, categorize the issue, and it will actually gives us the professional response. Okay. So let's see what it says. Let me run this here. So I'll just simply say Python space explore LangChain. It's a simple code to understand how LangChain works. Okay. So let's see. So right now I'm using OpenAI's GPT-4o mini. Okay. So I'll also change it to other models to show you how the responses will be different and how you can integrate other models as well. Yes. So you can see, guys, I got the response here. So you can see a lot of information we have. So you can see this is the actual raw response. If you see, JSON format, you can see. But the content is this. The actual content is this. Okay. So that is the idea. So if you see, because we said to analyze the sentiment, it is doing the sentiment analysis. It says sentiment expressed in the customer complaint is negative. So and so the issue, which issue it belongs to, and it is also giving some suggested solution. And also it is writing some professional response, right? Assistance with your account, and it's like a email, it's writing like an email, right? So, and the escalation. Okay. So like this, depending upon whatever prompt we gave, it is properly, giving us the required information. Now, what if I want to use another model here? I want to use Gemini. Okay, so just come back here, just change it to Google Gen AI, right? Let me change it to Google Gen AI. That will be the LLM provider, and we have the model name as Gemini, you know, 2.5 Flash, right? Let's use this and see what happens, right? So remaining all is same. Everything, the prompt, the response, everything is same. Just I change the model name and the type. That's it, right? So the libraries, everything is same. Yeah, you can see again you got a response from Gemini Flash, Gemini 2.5 Flash, and this is the output. Okay, it says okay, let's break down the customer complaint. This is a customer complaint. So it is doing some sentiment analysis. It is also doing some issue categorization, suggested solution, and also it is, you know, it is of course doesn't have the knowledge, but it is checking its internal knowledge, I guess. And finally, it is writing some email as well, right? So this is by the Gemini 2.5 Flash. Let's see by, by Anthropic, right? Claude model. So let me run this. This is by the Claude again. So you can see, right, how I'm able to shift the models. Oh, wait, there is an error. Okay, so there is a error, guys. That is it says, if you see, it says model ID is not found, right? So I guess we are not giving a proper model ID. So let me get the proper model ID. So you have to go to the, basically the respective documentation and get it. So right now I'll just use the old model ID, which I have already used. And, I will try to give it here. Done. Let's run that now. So this is basically the common issue. You should go to the documentation and see. You have to give the exact model ID, or else it will not, it doesn't know, right, which model you want to use. Yeah, now I got it. You can see. So now you can see again, this is by the Claude IQ 4.5, which again says the sentiment analysis, issue categorization, so and so, so and so, all the information. So you can see, right, with just a small changes in my init chat model, I'm able to access all the models. I'm able to just do a simple plug and play. That is the beauty of LangChain. Okay. Now let me show one more example, guys. This time a slightly a better example and bigger one. So this is, if you see in this example, what is happening right now? We are doing three things actually. First is identifying the sentiment, and the same LLM is also categorizing the issue. It is suggesting a solution and also writing a professional response. So you can see same LLM, one LLM is doing multiple things, right? One LLM is doing multiple things. So if you see the response also, will be getting multiple things at once. Okay. So as is a very simple use case, it's okay. But eventually, once you proceed further, once you do complex use cases, in that scenarios, doing all at once is not generally recommended, guys, because it is observed that in various research, in my research and in my experience, I observed that one LLM call or one LLM cannot do multiple things. Okay. For example, if you say LLM, now of course, whatever response you're getting might be good because it's a very simple use case. But just imagine you're doing some complex things and you are just doing all at once. It is not recommended, right? So imagine you're trying to debug a solution in your cloud. So LLM cannot do everything at once, everything at once. So in that case, what is recommended is whatever problem or whatever use case you're having, or whatever problem or whatever use case you're having, what I would recommend is first divide this into multiple modules. Okay, multiple steps, basically, I would say multiple steps. Again, this is for the complex use case, but I will show this use case as an example. Divide into multiple steps. Now, if you, in our case, if you consider, in our use case, what is happening? It is analyzing the sentiment, it is categorizing the issue, and it is also writing the professional response, right? What if instead of writing this or instead of doing this with one single LLM call, what if I do it with multiple LLM calls? So what do I mean by this is, okay, I'll have first LLM, which will do for me the sentiment analysis, only sentiment, okay? And that output is given to the second LLM or second LLM, which is basically categorizing, doing some category. And third LLM, which is basically, writing the response based on this sentiment and category, it will write the response for me. Okay. However, the message for this will be same, but you are not just using one single LLM to do this, but it's like multiple LLMs doing this. Okay. So why this way? Because you might also worry, okay, what if, because in this approach, you'll be having multiple LLM calls. You might be thinking like, here the problem is you're having multiple LLM calls, right? Yes, you're right. There might be multiple LLM calls as well. But the thing is, when you're working with complex tasks, with single LM call, you might get a lot of issues. Sometimes it misses something. Sometimes it might not give you the structured response what you want. Like that, there are a lot of issues. So in that scenarios, it is recommended to go with multiple LM calls and divide your complex thing into multiple things. Okay. However, in our use case, it is look simple, but eventually once we proceed further, you might need to handle complex cases. In that case, one single LLM or one single bot doing everything is, not recommended. And one more thing is right now we are using state-of-art models. If you consider Claude models, Claude IQ models, or Gemini models, or GPT models, are the state-of-art models. So they are good at doing these things. But imagine in our near future, we work with simple models, simple open source models, which is less parameters, 7 billion, 2 billion, 3 billion. In that case, these kind of module division will be helping the models better, right? So that is a reason why I'm showing you this approach as well, like how to divide this. Okay. And one more advantage is by dividing like this, you can also assign specific LLM as a specific task. Instead of using same LLM in all the three, you can also use same LLM in all the three categories. But instead of using the same LLM in all the three modules, maybe you can also use different LLM. Maybe you know that from your research, you identified that sentiment analysis, you identified that some Llama model was good. So I'll use Llama here. You identified that for classification, maybe GPT was good. So you'll use GPT-4 here. Maybe you identified for email writing or for response writing, Claude is fine. You observed that. So you use Claude. So like that, I can use for a specific task who is good at a specific task, and I can use that models as well. So in that way, for some cases, your tokens will reduce because cost of Llama is less compared with GPT-4 or Claude, right? So you can also reduce your token, something like that. Okay, something like that you can actually work with if you divide into multiple tasks. Okay, so let's see that example how to work with multiple chains. So here what I will do is, here I only created one chain, right? I have just created only one chain, right? Like one single chain where you're having a prompt with LLM. But in this scenario, what I will do is I'll create multiple chain. What I will do is I'll create a sentiment chain, I'll create a category chain. I'll create a response chain and, combine this with pipe operator. Okay. Sentiment chain, pipe operator with category chain, pipe operator with response chain, something like that. Okay. So let's see in the code and see how can we do this. Okay. So here you are having customer service agent.py. So here you can find the things which I was talking about. So as of now, guys, for the three chains, I'm using same LLM, but different LLM calls. So that is a difference. But I'll also show you how can you use different LLMs as well. It's very easy. So as usual, I'm importing some libraries. One is, the prompt template and string output parser. Again, here you'll be seeing a new one that is called as string output parser here. Again, don't worry about what is string output parser. It's like a parser, means whatever LLM output you're having, it will convert into string. But again, we are having a separate dedicated sessions for output parser, guys, where we'll talk about different parsers like string output parser, JSON output parser, Boolean output parser. But for now, understand that this is just converter, which converts your LLM output into string. So it is used as an output. After LLM call, we use this, okay? So it's like a parser. So string output parser, but we'll talk about this deep about this later on. Then you're having a runnable pass through. This I'll talk about this in few minutes. First, let's complete the normal one, and then I'll talk about why do we need this runnable pass through in the next step. Then we are having the init chat model as usual and the .env. Okay. So again, here we're initializing the chat model. Okay. Again, here I'm using GPT-4o mini with OpenAI provider, obviously. So if you see here, I'm creating three chains. First, I'm creating a sentiment analysis chain where I'm creating a sentiment prompt separately. And this job of sentiment analysis is to just and do the sentiment analysis. So I'm just sending the message here as an input, you can see, and it will do the sentiment analysis, just sentiment analysis. Okay, nothing else. So I'm giving the sentiment prompt, the LLM which I want to use, and the output parser, which converts your LLM output into proper string. Next, again, it is not compulsory. Using output parser is not compulsory, but you'll understand soon why do we need to use it in our next upcoming sessions. Then we're having some category prompt. Here we are just categorizing this issue. So we're having categorize this issue. Again, I'm just giving the user issue, user message. Message is nothing but the user, like a placeholder. This is the user issue. We are just giving the categories, and it is again identifying the categories. Then comes your response prompt. Response is the final email writing prompt where you're saying write a professional customer response, and you're giving the original message. You're giving the output of the sentiment and category as well. Means whatever output we get from the sentiment and the category chain, we are giving it and we are getting that response. So you can see you have created three chains here. One is sequential chain, right? Which is this using this pipe symbol. You can see sentiment prompt, LLM, and output parser category, and like this. You are creating three chains. Now we have to combine this chain, right? You have to compose all this chain into one sequential chain. That is nothing but this full chain. So now the thing is, our main chain is our response chain, right? Response chain will be the final output chain. So what we have to do is we have to use something called as runnable pass through. Runnable pass through means just pass through, means run this and next pass through the next agent or next chain. Okay, pass through the next chain. That is the idea of runnable pass through. So that is what we are having, and this is also is a part of the LangChain expression language, that is runnable pass through, where you are just running it and passing it out, passing to the next chain. Okay, so we are just saying runnable pass through dot assign, and here I'm just giving the sentiment chain first, then I am giving the category chain, and finally the response chain. And if you see all these three chains, I'm arranging like with the pipe symbol. I'm basically using the pipe symbol to combine all these chains. So first we have the sentiment chain, second is a category chain, and third is a response chain. So what happens here? It will sequentially run all these three. First, it will automatically run the sentiment chain, identifying the sentiment. Second, it will run the category chain, identify the category. Third, it will run the response chain and identify the response. So you can see we are just combining all this thing. And finally, I'll run this is my full chain. Now I'm just doing full chain dot invoke, and I'll just give the user issue, right? I'll say my order is late and I'm really frustrated. Okay, and we get the result here. Okay, so this is the idea of the simple multi-chain system as well, like not only single chain. If you're having multiple chain, you can just use this runnable pass through and you can actually combine this multiple chains as well, like this. Okay. And finally invoke it. So let me run this first and show you how it looks, how the output looks. Okay. So let me clear this and just let me run this. So yeah, you can see, right? This is the response we got. Okay, that is the final response. So from this chain, we are only expecting the final response. That is the email. That is what we have to send to the user. So you can see because it's from the response chain, which is basically, which is running this the final response. So the idea is something like this. Okay, so we identify the sentiment, we identify the category, and based on sentiment and category, we want to write the response. Our response to should be tailored to the sentiment and category. So you can see that is the final response we have. Okay, this is the final response we have from the LLM, right? That is nothing but our email, which is based on sentiment and category. So internally, so we don't see this, right? We actually send the sentiment and category internally, and it will use us that sentiment and category, and basically, gives us only the email which we will be needing and sending the user. That's it. That is the idea of this chain. Similarly, guys, now if you carefully observe here, this sentiment and also category, these both doesn't have a link to each other. Means sentiment and category can be run independently, parallelly as well. So that is where the parallel also comes. Now, what is happening in this case is, in this scenario, all these three are sequential. Means first the sentiment chain will run, then it will pass through, it will add the keys. It will automatically add the keys called as sentiment and category and pass through and it will pass it to the response chain, right? But I want to run the sentiment and category chain parallelly, means because the sentiment and category are independent to each other, correct? They can run parallelly such that, I can save some time instead of sequentially running it. So that is where you also have something called as runnable parallel. Okay. So in runnable parallel, what happens is, so this is the next code. So I've already actually I've commented it. So you can just uncomment this. You can uncomment this and basically you can comment this. You can comment this full chain dot invoke because we don't need to run this, right? So you can just comment out this full chain dot invoke and we uncomment this. So here, if you see, you're having something called as parallel chain. So in this, what happens is instead of using the runnable pass through, we use runnable parallel. Okay. And we are saying that this runnable parallel is used to run the parallel operation, right? So in the runnable parallel, we give the user message first. Okay. It will just passing through the user original message, which we get it from here. So we'll run the sentiment chain as usual. We'll run the category chain. And once this parallel runs are done, these parallel operation, we are using pipe symbol again to send it to the response chain. Okay, so it is same as previous, but the only difference is in this case it will run sequentially. So first it will run sentiment, second is category, and third is response. In this scenario, it will run the sentiment and category chain parallelly. Okay, it will run the sentiment and category chain parallelly. And finally, that response is given to the response chain. So that is the idea of parallel chain. So everything is same, parallel chain dot invoke, and finally I'll get the final response. So everything is same. The only difference is instead of using the, you know, sequential chain, that is the like two sequence, here you are just using this sentiment and category parallelly to save some time. That's it. Now you can see the response is similar. You can see you're getting the final response only, but the only difference is you're just, using the parallel run. So in this way, these are the examples of the LangChain expression language, guys. So in this way, you can actually build chains, and you can build both sequential and parallel chain using the LangChain. So I hope you understood the basic idea, understood the basic understanding of how a LangChain works, and why we need to work with LangChain. What is the advantage of using LangChain? So this is just a start. So there are a lot of things we have to discuss in LangChain, like how to work with advanced runnable things, runnable operators, and also how to work with document loaders, how to work with parsers, prompt templates, all those things we'll be discussing in our next upcoming videos, guys. Thank you.